You probably feel still right now. Sitting, standing, not moving. It feels obvious. After all, you're not walking anywhere. The room isn't rushing past you. Nothing seems to be changing. But here's the quiet problem. In physics, there is no clear definition of what it means to be truly at rest. Not because motion is confusing and not because you're mistaken, but because when physics looks closely, not moving always turns out to mean not moving relative to something else, relative to the chair, relative to the floor, relative to the planet beneath you. Change the reference, and stillness disappears. So while your experience of rest is real, physics suggests it may not be fundamental, which raises a simple but unsettling question. If nothing is ever truly still, what does motion actually mean? The feeling of being still comes from how your body and brain work together. Right now, your body is in contact with solid surfaces. The chair supports you. The floor pushes back. Your muscles aren't adjusting much. Nothing nearby is changing quickly. So your brain concludes something simple. I'm at rest. This makes sense. Your nervous system is built to notice differences, not absolutes. It tracks motion by comparing one thing to another. If everything around you moves together, there's nothing to signal change. This is why a smooth airplane flight feels motionless. At cruising speed, you can stand up, pour a drink, and feel completely still, even though the plane is moving faster than almost anything you experience on the ground. Your senses don't detect speed itself. They detect acceleration. As long as your motion is steady, your body treats it as rest. The same thing happens on Earth. You don't feel the planet spinning beneath you. You don't feel it orbiting the Sunday. You don't feel the sun moving through the galaxy. All of that motion is shared. So from your point of view, it disappears. Over time, this experience becomes intuition. Not moving feels like a natural state. Motion feels like the exception. But this intuition is local. It works because the reference frame you live in is stable and familiar. Your brain locks onto it and treats it as the background of reality. Physics doesn't do that. It never asks whether something is moving absolutely. It only asks, moving compared to what? And that difference between intuition and physics is where the idea of absolute rest begins to quietly fall apart. Here's the first place where physics quietly disagrees with intuition. In everyday thinking, at rest sounds like a complete description, but in physics, it's incomplete because rest is never absolute. You are at rest relative to your chair. Your chair is at rest relative to the room. The room is at rest relative to the Earth's surface. But the Earth is rotating. At the equator, you're moving at over 1,000 miles per hour just by standing still. The Earth is also orbiting the Sunday. The Sun is orbiting the center of the galaxy, and the galaxy itself is moving relative to other galaxies. So which of these motions counts? Which one defines whether you are truly still? Physics doesn't choose. It never says, this frame is the correct one. Instead, it treats all steady motion as equally valid. This is the core idea behind relativity. The laws of physics work the same way. Whether you're sitting quietly in a room or gliding smoothly through space, there is no experiment you can perform inside a sealed, smoothly moving system that tells you whether you're really moving or really at rest. Motion without acceleration has no physical signature. That's why the concept of absolute rest never appears in fundamental physics. There is no preferred background, no cosmic standstill, only motion relative to something else. This isn't a limitation of measurement. It's a statement about how the universe is structured. You can always describe yourself as still by choosing the right reference frame. And you can always describe yourself as moving by choosing a different one. Both descriptions are correct. Once you accept that, rest stops being a special state. It becomes just one way of describing motion from a particular point of view. And that realization opens the door to a deeper question. If physics never picks a true state of rest, why does motion seem to need one? Let's try a simple thought experiment. Imagine you want to answer a basic question. Are you moving or are you still? To do that, you need a reference. So you pick one. You say, I'm still relative to the earth. That feels reasonable. The ground beneath you isn't sliding away. Buildings aren't drifting past. But then someone asks, why the earth? Why not the sun? Relative to the sun, the earth is moving at about 67,000 miles per hour. So now you could say, I'm moving, but then why stop there? The sun itself is moving around the center of the Milky Way, and the Milky Way is moving relative to other galaxies. Each time you zoom out, the answer changes. At no point do you find a special place where motion suddenly disappears. There is no marker in the universe that says, everything stops here. You might try to pick the universe itself as the reference, but physics doesn't offer a single object that represents the universe at rest. There is no universal background you can measure your motion against. Every candidate you choose is just another moving system within a larger one. This is the key realization. Stillness is not something you discover, it's something you define. You choose a reference frame, and relative to that choice, motion either appears or vanishes. Physics allows this because no choice is physically privileged. All steady frames are treated equally, and this equality is not philosophical. It's built into how the laws work. Change your frame of reference, and the form of the laws stays the same. Nothing breaks. No contradiction appears. This means the universe does not contain a hidden notion of absolute rest, waiting to be uncovered. If it did, physics would be able to detect it. But every experiment designed to find it comes up empty. The absence is not accidental. It's telling us something fundamental. Motion is not defined relative to a fixed background. It is defined only through relationships between you and the ground, between the ground and the planet, between the planet and the stars. Remove the relationships, and the question, who is moving, loses its meaning. By the end of this thought experiment, something subtle shifts. You stop asking, am I moving or not? And you start asking, moving relative to what? At this point, a pattern becomes clear. Physics never asks which frame of reference is correct. It only asks whether the laws work the same way in all of them. And remarkably, they do. Whether you describe a system from the point of view of someone standing still or someone moving smoothly at a constant speed, the equations remain consistent. This principle is so central that modern physics is built around it. If one frame were truly at rest, it would stand out. The laws would look simpler there. Experiments would behave differently. Motion relative to that frame would leave a detectable trace. But none of that happens. Every attempt to identify a special state of rest has failed. Light travels at the same speed, regardless of how fast you are moving. Clocks tick according to motion, not according to some hidden background. There is no experiment you can perform inside a smoothly moving system that reveals its motion without looking outside. This tells us something important. Rest is not a property of an object. It is a description that depends on perspective. Physics doesn't say, this object is at rest. It says, this object has zero velocity in this chosen frame. Change the frame, and the description changes. But the physics does not. This is why motion turns out to be more fundamental than rest. Motion is relational. It exists between things. Rest is just a special case where that relationship happens to produce zero relative velocity. Nothing about the universe singles that case out as special. And this is where intuition quietly breaks again. We tend to think of rest as the default and motion as something added on. Physics reverses that picture. Motion is the baseline. Rest is a convenience, a way of simplifying a description when it happens to work. Once you see this, the idea of a universe filled with motion starts to feel less strange, because it's not that everything is rushing somewhere. It's that there is no underlying stillness for things to rush away from. Once rest stops being special, the picture flips. Instead of asking why things move, physics asks something simpler. Why would anything ever be still? In a universe without a preferred background, motion doesn't need an explanation. It's the natural state. Objects continue moving, not because something pushes them, but because nothing tells them to stop. This idea is deeply unintuitive, because our everyday world is full of friction, air resistance, contact force, surfaces pushing back. These effects constantly drain motion away, making rest feel natural and motion feel temporary. But friction is not fundamental. It's an emergent effect that appears when many particles interact. Strip it away, and motion persists. In empty space, an object will keep moving at a constant speed forever. No fiel, no effort, no preferred direction. From this perspective, rest is not the absence of motion. It's motion that has been balanced by interactions with the environment. Remove those interactions, and stillness disappears. This is why physics treats motion as the default description, not because things are always speeding up, but because constant motion requires no cause. Acceleration does, changes in motion do, but motion itself is simply how objects exist when nothing interferes. Once you see motion this way, the universe looks less like a place where things occasionally move and more like a place where motion is quietly everywhere. And in that universe, rest becomes what it truly is, a convenient approximation, a momentary balance, not a fundamental state. So the feeling of being still was never wrong. It was just incomplete. Your experience of rest is real because it's based on relationships that don't change around you. But physics tells us that those relationships are not fixed in any absolute way. There is no universal background that defines what it means to be at rest. Only motion relative to something else. In that sense, motion isn't something that happens to the universe. It's how the universe is described. We move not because we are pushed, but because nothing in physics asks us to stop. And when motion is steady, it becomes invisible to our senses. That invisibility is what we call rest. So perhaps the deeper lesson is not that nothing is ever still, but that stillness is something we create by choosing how to describe motion. And that leaves one final question. If there's no absolute state of rest, what do you think it really means to be not moving? I'd love to hear how you think about it.